Hi, thanks for checking out our channel. There's going to be a hopefully repair video on a Dare Enforcer model DE400. This is a 1 output joule unit, probably like 2 stored or 1.5 stored. But the customer wants us to get this going, and then also if we can get it going, wants us to try to beef it up a little bit, make it a little stronger. So we can probably do that with this one. This one's shared with a couple other models, I think, and that are larger than this one joule-wise, but have the same case size. So we're probably going to repair it, and then we'll test it to see what the output joules is at that point. Then when we can go in there and try to upgrade the guts a little bit, and maybe get to put out a little bit more power. So we'll go and we'll pull it apart here first, and then we'll I'm not going to plug it in yet, 'cause I don't know what's wrong with it. But we'll do that first, and then we'll see what it looks like. Do a little bit of testing on the inside. Power surge. Let's see how already on the AC side, the fuse is blown. It stinks in here as well. It smells like electrical burn smell. See it blew the fuse is blown, but there's a lot of burnt stuff right there as well. So, and it looks like there's some dead bugs inside, so maybe it wasn't a power, so maybe the bugs got in there and caused that deal. So probably have to replace the board, which I've got those in stock. And let's we're gonna plug these 2 wires first. This is our capacitor wires. And then we need to pop this board up. It's on a pretty firm. Oh, jeez. See if we can get these wires pulled through. And if you'd like to have need parts for this unit, call me, which is on that number on that card I showed you a minute ago, and we can help you out with some parts if you'd like to do the work yourself. Come on, get off there. Oh yeah. Possibility we could clean it up and fix it, but I'm always worried about it re-arcing and causing more issues. So, and the parts for these aren't super expensive to start with, so it almost doesn't pay to fix the board and swap another one in. Ooh. Transfer's pretty arced up looking too, but that could be cosmetic. Let's check the primary of the transformer. I believe on this one, it's these 2 terminals here, so we're going to put our meter on ohms, and it should be very low ohm, like 0.1 to 1 ohm, reading 0.2. I don't remember what this side's supposed to read. 2.5, that could be right, I don't know. They call it, really, the output ohms resistance of a low impedance demonstrator will vary from model to model, brand to brand. They all kind of range between, I guess if this transformer is good, between 2 ohms and like 35 ohms. And there's not like a one-size-fits-all reading that these will read. Need a better pair of pliers. This one's a little. Let's take this capacitor out. See, this is a 7.5 microfarad capacitor. See, how old is this thing? It is a 2010. The back unit has this manufacturer number on there, 0310. This one's, so the first 2 digits are the month, and the second 2 are the years. So this is manufactured in March of 2010, so it's a 14-year-old unit. And the board's at a revision date of 2008. So this being 2010, so this is probably the original board. I don't know if they've made any changes to this board since then, and I will get another board for it and install it, and then we'll see what it reads. So let's check this capacitor next. Put a meter on capacitance, and we'll test across it. Well, capacitor's no good. Not reading at all. Let's go across the actual terminals here and see. Maybe just got bad connection or something. No. So the capacitor's junk. So that might have been his whole original problem. But when the ants got in there, or power source got it, that really hurt it at that point as well. So okay, so 7.5 microfarad capacitor with this board combination made this unit a 1 output joule. So if we put a 15 in there, we think in theory it would jump us up to a 2 joule. If we put a like a 20 plus 25 joule or 25 microfarad capacitor, that might get us close to that 3 joule range. So we'll try to. And this unit will handle, I know that this model design, the biggest that I know of that they sell in this case design is a 3 joule. So we know that this transformer can handle up to 3 joules, if not a little higher. So I think there's enough room down inside here we can put another capacitor there. So let me go get some parts and we'll start reassembling stuff. Alright. We got the board here. We got a capacitor there. So we know we got to get this capacitor installed. And what we'll do is we'll probably, this is a 20 microfarad capacitor. We'll set it right there. We'll put some 2-part epoxy on it, and we'll glue epoxy capacitor right against this back case. So if this capacitor ever goes bad, which might be 10, 15 years, 20 years from now, we can still take something and drive that capacitor out of there. So if we need to ever replace it, we can. But it didn't have a stud on the back to bolt it to the case like the other one did. So let's this is made to be plugged into a board and soldered on, but what we're going to do is we're going to put some solder on the terminals here. And then we're going to reuse these wires. We're just going to cut the ends off. Add some solder to the ends. And we'll solder them on to the capacitor. Let's hold it side by side. Ow. That's hot. That looks better. Same thing to this one. We'll heat the solder up. hold it side by side. This is a little long, a little exposed, so we'll snip off some of that. Don't need that much on there. Okay, so this will sit right there. Alright, so we're going to slip these wires up through here. Pull them the length here in a second, but let's get this board set on here. All the tabs are straight and lining up, so now we can just give it a tap, press it into place. Alright, so capacitor 1 goes right there, so another wire goes right here. Now we can feed the wire back through the case a little bit. Come on. There we go. All right. Let's mix up a little bit of 2-part epoxy here. Don't need a lot. I need a stir stick. Press it back into place right there. Alright, so now let's flip this around. This one should go to working, as long as that nothing arcs anywhere it isn't supposed to. Push that board's all the way down, nice and level and straight. Alright, so we're going to take these knobs off, and we're going to test for voltage. This is usually about 6,000 to 7,000 volts out of this thing, I think, somewhere in that range, and then we'll test the joules. So before, based on the stamping on the front of the case, it was a 1 output joule unit. Right, it's clicking again. So let's get our meter out, and we are going to check the output joules of the unit, which okay, so we're going to look at this number for kilovolts, and then based on our switch setting up here, we are on kV and joules, so we're on this top, the big letters numbers. So this one's going to be our kilovolts, this is going to be our joules, output joules, and we're going to do it under no load first, so we can see what our peak voltage, and it's not going to be doing any work, so all we're going to do is get a kV reading, no joules. So we reverse it just to see if it makes a difference. So we're at about 5.5 kV, almost 6,000 volt, which is I think normal for this unit. We're going to go to a 500 ohm load. The voltage should drop a little bit, but the joules should be something. So we're at 5.3 kV at almost 2 joules, so we've almost already doubled it so far just by doing that. So we'll do it to a 200 ohm load. The voltage should drop, and hopefully the joules should climb. We're at 4.5 kV at 3.1 joules, so we've already tripled the amount of energy coming out of this thing. We're at 3 joules. It was at 1. It's just for shits and giggles. We'll go to a 100 ohm load. This will probably really hurt it. We'll see. Well, still 3.5 joule output at 3.6 kV. So I'll climb up a little bit more. So let's go back to no load, and we'll see what the pulse speed is on it. So now we're going to be basically on seconds and milliseconds, which is this one and this one. So this will tell us how, this number here now will show us how often it clicks, like what its pulse speed is. And this will be like the duration of the actual shock itself. So a pulsing clicking time is 1.3 seconds in between each click, which is normal. And the duration of the shock is 0.05, 0.06 milliseconds. So really sharp discharge and shock durations. But 1.3 is about normal. Most brands kind of float between 1.1 and 1.5. This is for see what kind of spark this thing will throw. We're going to go. There's a spark gap right down inside there. You can see right there, like a lightning spark gap. Put a screwdriver down there and we'll see what kind of spark it'll throw. So a nice little spark. Camera's not doing it any justice. So, yeah, this one's working fine. Alright, so we're going to put this back together. Call the customer up. They wanted us to try to make it stronger, and we did. We got it all the way to 3.5 joules, so we basically a little more than tripled it power joule wise. We went from a 1 joule to a 3.5 joule output, so quite a bit more power coming out of it. Alright, well that's it for this video. So next time, see you guys later on. Remember to tell your friends, subscribe to the channel. If you'd like to get parts from us, get a hold of us. We'd be happy to help you out with parts. Until next time, we'll see you later on.